Hi boys and girls, welcome to your video on independent versus dependent variables in probability. Make sure you fill out your guided notes as we go throughout the video. If you need to pause the video at any time, please feel free to do so. Alright, the first thing that I'm going to do is define independent and dependent variables or events. So independent events, the occurrence of one event does not affect the likelihood that another event will occur, whereas dependent events is the occurrence of one event does affect the likelihood that the other event will occur. So now we're going to take a look at an example of both. So this is an example of an independent event. So if you flip heads on one coin and tails on another coin, the outcome of flipping one coin does not affect the outcome of flipping the other coin. Therefore, this is an example of an independent event. So because they're two separate coins, the probability of the one coin flipping a tails does not affect the other coin flipping a tails. Now, an example of a dependent event. So say, for example, your teacher chooses one student to lead a group and then chooses another student to lead the group. So the teacher cannot pick the same student to lead both groups, so there are fewer students to choose from when the leader of the second group is chosen. So this is an example of a dependent event. So if I picked one student from the class and then picked another student, because I removed one student from the group, the probability changes. So therefore it is a dependent event. Let's look at the formulas that are used, or equations that are used to determine both. So the probability of two independent events, A and B, is the probability of A times the probability of B. Now this is already given to you in your notes. So we're going to take the probability of the first event and multiply it by the probability of the second event. So let's look at an example. So say you flip two quarters. What is the probability that you flip two heads? So let's look at the probability of each occurrence first. So the probability of flipping a heads is 1 out of 2. Because there's one heads and there's two sides on a quarter. And then the probability of flipping a heads on another quarter is still 1 out of 2. So 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. So the probability of flipping two heads on two quarters is a 1 out of 4 probability. Now let's look at an example of dependent events. So the probability of two dependent events of A and B is the probability of A, so the probability of the first event, times the probability of the second event after the first event occurs. Again, and this is already given to you in your notes, so let's look at an example. So you randomly choose a flower from the vase to take home. Your friend randomly chooses another flower from the vase to take home. What is the probability that you choose a purple flower and your friend chooses a yellow flower? So again, we're going to find the probability of the first event, which is the probability of picking a purple. Well, in our little key here, we have 7 purple flowers out of how many flowers total. So in order to find that, I'm going to add all of these together. So we have 12 plus 9 plus 7, equals 28. So there's a 7 out of 28 probability of picking a purple flower. Now the probability of the second event is picking a yellow. Well, there's 9 yellow But because of the first event, I already pulled a flower, there's one less flowers in the base. So therefore, it's 9 out of 27. And then I'm going to multiply these two fractions together. Both of these can be reduced. 7 out of 28 is also the same thing as 1/4. And 9 out of 27 is the same as 1/12, or 1/3, sorry. So 1/4 times 1/3 is 1/12. So there's a 1 out of 12 probability that you will pick a purple and your friend will pick a yellow flower. Okay, make sure you bring these notes into class tomorrow. If you need to go back and watch any part of the video, please feel free to do so. All right, have a great night, and I will see you tomorrow.